Excuse me. I'm going to use the document cam today because I couldn't get the calibration right before class, and I'm going to work on it after class. I didn't want to take up more time to do that. The Russians did something to it. I hadn't had a chance to look at the homework. I went through and took off a lot of the questions that cause problems. So I think it's going to be around 5.3 or 5.5 that we actually start doing the antiderivative. So I'm going to go ahead and jump on into the antiderivative today and start showing you how to take the antiderivative, especially up to, the first 5 properties. Because, of course, the trigonometric functions, those are going to be the opposite. So the antiderivative of the sine is the negative cosine. The antiderivative of the cosine is the sine. So those can kind of take care of themselves because you just memorize those. So let's go ahead and jump into antiderivatives. Now again, there's 2 types of antiderivatives. There is the finite derivative and the infinite derivative, okay? Or whatever you want to call it. The finite and the infinite. The finite has parameters. The infinite does not have parameters. The infinite, usually you have to worry about adding c to it. And we'll get to that in just a minute. Whereas the finite, you have to actually do calculations. Now, as we talked about before, sometimes teachers do not ask you to do the calculations. Sometimes the homework problems will just ask you to set up the antiderivative. But sometimes they will ask you to do the calculations, and we'll get to that when we get to it. But when you're talking about an infinite derivative or an infinite antiderivative, you're talking about family of equations. And the family of equations is what refers to the C. For instance, if I ask you to take the derivative of 2x squared plus 4x plus 1, you would give me f prime of x is equal to 4x plus 4. If I ask you to give me the derivative of 2x squared plus 4x minus 6, you would give me f prime of x is equal to 4x plus 4. Now, the derivative is the same, but the derivative here refers to this function, and the derivative here refers to this function, and the only difference between the 2 functions is the constant. So that's why when you're taking the antiderivative and it's an infinite problem, you always put the c here because that c is going to be representative of a positive 1, of a negative 6, of a positive 500, of a negative 127. Whatever that third term is, that C is going to represent. Now, how do you take the antiderivative? Well, as I showed you on that property, the antiderivative, let me give you an example of an antiderivative with an infinite antiderivative. 3x squared plus 4x minus 3 dx. That's what an infinite antiderivative looks like, because it doesn't have a number here and it doesn't have a number here. A finite antiderivative is one where you're finding the area under or in between or between curves or under curves. If I give you a function, excuse me, I've got Rona, and that's A, and that's B, and I want to find this area between A and B, then I'm going to set that derivative up, antiderivative from A to B, and let's say this function is, I don't know, let's just say, I've got bad network quality, I don't know why, f of x, and I'll just put f of x right there, and that's going to be f of x dx. And here are your parameters, and that's why you have a finite antiderivative. Questions so far? Okay. Any questions so far on the difference between a finite and a infinite? Y'all ain't very talkative today. Are y'all even awake? I know Miss Sterling is. I heard her. Anybody else out there? Miss Hart? Miss
Sterling? Yeah, no, I was talking to you, but I guess you couldn't hear me.
Oh.
Because your internet connection was bad, but I don't have any questions.
Okay. All right. So we're going to be working with both. And your test for this unit will have both on there. Okay. Let's do some. Let's go ahead and start some, and let's look at again the first two properties. The derivative of a constant or derivative of a function, and there's nothing there, that's going to be x. The derivative of a power, those are the two we're going to start with. Now, with antiderivatives, you can do some of the same things that you can do with antiderivatives that you did with derivatives. You can pull out a constant. You can do terms. Now, there's not a lot of antiderivative functions yet. You're going to learn some in Calc 2, but you don't have as many like you had the product rule, the quotient rule, the chain rule. You're not going to have as many of those, okay? Basically, these are your main two right here. And then you have an e, you have natural log, and then you have an exponent. That's it, okay? You don't have any product rule or quotient rule. There is substitution. We're going to get into substitution, and that's probably your most confusing to some of y'all. That's probably the most confusing. So we're going to work on these two. And we're also going to talk about the different little properties that we talked about the other day about, you can actually, if you have the antiderivative of 2x squared dx, Well, you can rewrite that as 2 antiderivative of x squared dx. Okay? Now, a lot of people say, well, Hubert, what is the dx for? Well, what is the area of a rectangle? The area of a rectangle is the height or your base. And remember from Riemann, that's called what? Delta x. And then this is your height, and that's going to be basically x squared. Take your length or your base times your height. That's why you have that. That's why it's written like that. dx stands for delta x, but it also stands for, if you took the antiderivative of something, you have to have the dx in there to take the antiderivative of it. Okay? So just think of it as an appendage. Think of it as something you have to do when you're doing the antiderivative. So the constant rule says I can pull that 2 out. Okay? Another rule, if I've got the antiderivative of 3x squared plus 4x minus 2 dx, I can break that up into 3 antiderivative of x squared dx plus 4 antiderivative of x dx minus 2 dx. Oops, sorry. Okay? And I can break up terms. So constant rule still applies, and the term rule still applies. I can break it up into terms, or I can do a constant rule. Can I still do algebra first? Yes. In fact, it's very recommended that you do the algebra first on some of these, because if I give you the antiderivative of x plus 2 times x minus 1, well, there's not really anything you can do until you do the what? The algebra. And you get x squared plus x minus 2 dx. Rewriting. Don't forget to rewrite. If you have a radical, the antiderivative of, and this is, we're going to get into this later because this is substitution, the square root of 2x plus 4 dx, then you're going to rewrite that as parentheses 2x plus 4 to the 1/2 power dx. Now we're going to get into this later. This is where we do substitution. So we ain't got there yet. This is about the 3rd or 4th step after we learn the basics. Okay? Right before we go into trig, we learn the substitution method. Okay, make sure if you've given the antiderivative of x to the -4th, or x1 over x to the 4th dx. Again, you would rewrite that x to the -4 dx. So a lot of the things that you learned with derivatives, you're going to carry over to the antiderivatives as far as basic properties. The first property, besides the constant rule where you pull the constant out, is if you're given the antiderivative of x dx. I'm sorry, not x dx. Sorry. The antiderivative of dx. You might as well go ahead and put a 1 here because that's what that means. Now, if I give you this, you don't have to put anything because you know what that is. But when you just have dx written like this, you need to put a 1 there. And you need to go back to basics because this is basically the constant rule reversed. Okay? The power rule of antiderivatives basically is this. x to the n plus 1 over n plus 1 plus c. That's the power rule for antiderivatives. Let's go back, and I'll show you that right quick. There it is. The antiderivative of x to the n dx is right there. That's the power rule. So as I tell students, go back to the basics. Every function has a variable and a coefficient. Well, this one don't have a variable. Yes, it does. I'm going to rewrite this one as 1 x to the 0 dx. 2 x to the 0 dx. And now you can put a plus 1 there, and then put a plus 1, 0 plus 1 here, and a 0 plus 1 here. And that's going to give you the first one, that's going to give you x to the first over 1, which is x to the first plus c. And then this is going to give you 2x to the 1 over 1, which is equal to 2x plus c. So the first rule is right there. I'm sorry, I didn't show you. There we go. Okay, so the first rule is called the constant rule, basically. Is if you're given dx, then that means that you've got x to the 0, because that's what that is, and then you add, so your answer is going to come out to be x. So if this was a 3 dx, your answer would be 3x. If it was a 4 dx, it would be 4x. Okay, now let's do the power rule. Very important that you understand the power rule. Power rule is what's going to break you. So here we go. F of x, or sometimes, now I will tell you this, sometimes my brain is in derivative mode and we're in antiderivatives. So if I say derivative, it's okay. Everybody understands I mean antiderivative. But sometimes sometimes I'll do antiderivative of x squared and I'll go 2x. All right? That happens, okay? Sometimes that happens. It's just a mistake that you make when you've been dealing. I mean, we have been dealing with derivatives for what, 3 weeks? Okay? You've still got derivatives in your head. So don't go crazy if you do that, because it happens. So antiderivative of 3x squared plus 2x dx.
Lay down.
Say again. Anybody got a question? Okay, now I'm not going to do it like I've been teaching for 25 years, or I'm not going to do it like I've had calculus 2 or 3 times. I'm going to do it from the aspect of the person that ain't never seen this before. Okay, there's a difference between ain't never seen this before and I haven't seen it before. There's a difference. So the first thing I'm going to do is I'm going to use the term rule, and I'm going to break it up into 2 terms. And then I'm going to use the constant rule. Okay, so really, I haven't done any integration yet. And here is the integration. And I'm going to try to do this to where y'all can see it. Let's see. What should I do? I should go ahead and rewrite everything. So 3 parentheses plus 2 parentheses plus c. Now you will see in the homework and some of the tests, they will have that c outside the box. Okay, so you don't have to write it. But there are some teachers, I had one of these teachers. If you had 10 problems and you got all 10 problems right and you left the C off, he would mark every one of them wrong. Okay, so you do have teachers like that. I just want you to be aware of those type teachers. All right, so I'm going to use a pink pen. And I like black and pink together, so we're going to use black and pink. And I'm going to put x squared, and then I'm going to put plus 1 over 2 plus 1. And that's the integration. So this one over here is going to be x to the first plus 1 over 1 plus 1. So your final answer, well, I'm just going to rewrite everything. 3 times x to the third over 3 plus 2 times x squared over 2. And in this case, what happens to the denominator and the numerator? Does this happen a lot?
Yes.
Yes, it does. So don't feel bad if you have some things cancel out. Your final answer to this question is x to the third plus x squared plus c. That is the antiderivative, the infinite antiderivative of 3x squared plus 2x. Now, I just showed you the basics. I just showed you from somebody out of trig, never seen calculus before. Oh, why don't we mention how much of this is actual calculus? There's your calculus right there. Now, a lot of people don't have a problem with this problem. I show you this problem and you go, hey, that's pretty simple. Okay? That's not the problem. Just like when you first saw this in algebra, x plus 3 is equal to 6. Oh, that's not a problem. But when I put the distributive law with it, and when I put clearing the fractions with it, and I put all these other things with it, that's when people start going crazy. So I can put some stuff with this to make life difficult. I can rewrite it. I can put a radical over it. We're going to go over substitution here in a little bit, just to show you what to do if you do get something that doesn't look right. Okay? So on a scale of 1 to 10, this is about a 1, something like antiderivative of 2x squared dx. That would be a 1, which would be 2x to the third over 3. That's another thing. What happens when you get a fraction? Well, what do y'all do when y'all get a fraction? Y'all blow up because y'all don't know what to do with a fraction. So let's do a fraction and see what happens. Antiderivative of, let's do that problem we just did. 2x, or what did I write? 2x to the what? 2x to the second. What did I write? Hold on a second. Yeah, 2x squared dx. Now again, I'm going to write everything out. So I'm going to put a 2 out front. And that's going to be x squared dx. And I'm going to write 2 parentheses x to the third over 3 plus c. Now, there's different ways to write this, since you can't cancel. I write mine like this: 2/3 x cubed plus c. Or you could say 2x to the third over 3 plus c. So that's the number 1. Or another number 1 would be something like antiderivative of, dx, 4 dx. That would be like a number 1. What are you going to say, Miss Hart?
I'm not
heard Miss Hart. Okay, just say it. You got to say it. Say it. I thought you had something to say. Okay. So let's go ahead and write. Let's do some rewriting. So let's go with the antiderivative of 4x to the negative 6 plus 5x to the fourth minus 3x to the third plus 4x minus 2 dx. And this is a 3 or a 4. In other words, you've got some things in here that you need to address. Now, I'm going to do it basic. I'm going to factor everything out, and I'm going to do it by terms. Because if you ever get confused, always remember you can do it by terms and break everything up. So that's going to be a 4 antiderivative of x to the negative 6 dx plus 5 antiderivative of x to the fourth dx minus 3 antiderivative of x to the third dx plus 4 antiderivative of x dx minus 2 antiderivative of dx. And I'm going to go ahead. Okay, plus c is going to be down here. So I don't know how long this problem is. So that's going to be 4 parentheses. And I'm going to do everything in pink. X to the negative 6 plus 1 over negative 6 plus 1 plus 5 parentheses x to the fourth plus 1 over 4 plus 1 minus 3 parentheses x to the third plus 1 over 3 plus 1 plus 4 parentheses x to the 1 plus 1 over 1 plus 1 negative 2 hold on a second, negative 2 times x, sorry, I got to x to the 0 plus 1 over 0 plus 1. And of course that c is going to follow the answer. And the reason I did that in pink again, that's going to represent the calculus because we just did the calculus. So 4 negative x to the negative 5 over negative 5 plus 5 x to the 5th over 5. That ain't nothing but a coincidence. I'm sorry about that. Minus 3 x to the 4th over 4 plus 4 x squared over 2 minus 2x over 1 plus c. And that's going to be negative 4/5 x to the negative 5. You could bring that negative 5 down. I'm going to rewrite it down here. Plus, I'm going to go ahead and take my red pen and take out anything I could take out. That 5 will go out, and that 4 will go out and leave a 2 there. Okay? So x to the 5th minus 3/4 x to the 4th plus 2x squared minus 2x. And you could bring that down. I'm just going to rewrite this. That would be negative 4 over 5x to the 5th. And then plus ... plus c. So now if you got that answer and you did it ahead of me, that's great. But if you were doing it and you were kind of like, okay, where do you get that? What do you do there? Or what? Then you need to pay more attention, because I'm going to be going over more and more. And I don't want to insult anybody's intelligence, but at the same time, I guarantee you, Miss Hart talks about that physics class. I guarantee you there's several people in that physics class that don't have a clue on the calculus that they're doing.
Including the teacher, probably.
Uh-oh.
She's not lying about that.
Who's the teacher?
I don't want to say names.
I mean, I don't know anybody that teaches in physics. I don't know anybody. They're all gone. All the people that I knew, they either retired or they moved on to another school. I don't know anybody.
Kevin Williams.
I don't know him.
That's probably best.
But I
Okay.
have to solve for C, so this is easy what you're doing so far.
Yeah, and we're going to get to the substitution. Is it substitution?
I don't know what I did. I just know I solved for C. So
You just did your what? I'm sorry, I didn't hear you.
I don't know what we did. I just know I solved for C. Because
Oh, okay.
he gave something. I probably was substitution.
Probably integration by parts. Does that sound familiar?
No, we don't do much of it, so I don't really worry about it.
That sounds like integration by parts or by partial derivatives. It sounds like partial derivatives. But anyway, all right, so let's try our old friend, the square root symbol. So antiderivative of the square root of, oh no, we can't do that yet because I hadn't. Well, now let's go ahead and do some substitution. Might as well. I didn't want to, but I can go ahead and show you something really, really, really easy.
You make it sound like we're twisting your arm.
No, I just don't want to. I don't want to overload the cart. And when you're doing, especially with substitution, it's overloading the cart sometimes. All right, so we're going to go with 4x minus 2 dx. Now, how do I know this is a substitution? Well, for one thing, you're going to have parentheses. And whenever I told you about the chain rule, I told you to watch out for those parentheses. Chances are, when you're doing the substitution, you're going to have to worry about the chain rule or thinking like the chain rule. So the first thing I'm going to do is rewrite it. Antiderivative of parentheses 4x minus 2 dx. Now, I see those parentheses, and the first thing I think about, is what's inside. First thing I think of. Because if I have, and the formula, if I have the antiderivative of u du, then all I have to do is do u to the n plus 1 over n plus 1. Okay, and I'm going to put that in a pink highlighter because I want to think about that. That's what I'm shooting for in this problem. I want this. I want a function here and the derivative of that function right beside it. Okay? So, and this looks complicated, so chances are we're going to be using this. So the first thing I do, and you're going to see me do it later in my head, you're going to see me do u equal to 4x minus 2. Therefore, du is equal to 4 dx. And I have a dx right here, but I need du, I need the whole thing. So what I'm going to redo, I'm going to rewrite this. I'm going to put 4x minus 2 to the 1/2 power, and then put dx out here, a little space here. Okay, if I want this to be u du, there's u. If I want this to be du, I got to have a what in front of that dx? I got to have a 4 in front of that dx. And if I put a 4 in the integration, then I've got to put a 1/4 on the outside. Somebody tell me what 1/4 times 4 is.
1.
Okay, so I'm not changing mathematically. All right, so that gives me 1/4 antiderivative of u to the 1/4 du. Okay, what is u? 4x minus 2. What is du? 4 dx. I've got u du. So I'm going to take my handy dandy. Mr. O'Quinn, you said twist an arm on what? I didn't know what. I didn't hear.
I don't want to do this. I don't want to do this. Oh, we're going to do it anyways. It's like.
Well, I'm trying to do it in a moderate, fashion. I'm trying. I don't want to just roll you over. How about that? And there's you. Okay, so my answer, I now just do the, now I haven't done any calculus yet. So now I'm getting ready to do the calculus. So that's going to be u to the 1/4 plus, let me do the pink. Okay, now this is where half of y'all are going to not know what I'm doing. Over 1/4 plus 4/4. And that's multiplied out front by that 1/4. Okay, now I want you to finish it because we're done with the calculus. So go ahead and finish it and give me and we're going to replace the u last. We're going to put that 4x minus 2 back in. So that's going to be That's going to be 1/4 times, that's going to be u to the 5/4 over 5/4. Well, when we divide by a fraction, what do? We multiply by the what?
Reciprocal.
And of course, the 4s go out. And you're left with 1/5 times 4x minus 2 to the 5/4 power plus c. That's called substitution. Usually a dead giveaway for substitution is either the radical or the parentheses, usually. And sometimes you will already have a 2 in the problem and you don't have to put the 1/4 out front.
My question is the u to the 1/4. Where'd that 1/4 power come from?
Oh, God. It's supposed to be 1/2. I'm sorry. I just changed it. I guess I can't read my own dang handwriting. Should have said something before. Okay, that's supposed to be 1/2. And that's 1/2. That's 2/2. That's going to be 1/2 plus 2/2. So that's going to be what? 3/2. 3/2. 3/2. And that's going to be 2/3, right? 2/3, the 2 goes out, that's going to leave a 2 down here, 1/6. I should have just changed this to 1/3 or 1 whatever. Sorry about that. 1/6. Mr. O'Quinn, you're supposed to ask those questions right in here.
I was assuming I missed something up until that point.
What?
I was assuming I just missed it.
No, I think what I was doing is I was writing the 1/4 right here, and I think I just rewrote that as 1/4. My bad. That's substitution. Now, I've just shown you several infinite. Okay, I just showed you several infinite. Now let's do a couple of finite. Let's do a couple of problems that are, and we're going to do a couple that are very, very familiar to you. F of x is equal to, let's go with, well, not f of x. The antiderivative from 0 to 4 of x squared dx. Something very simple. We know that the x squared looks what? It's a parabola. And we know that we're going from 0 to 4. So that means 1, 2, 3, 4. So that means we're going to be finding this area. So we're going to be finding that area right there. Now we don't use C here because C is not used with finite. So this is going to be x to the third over 3 evaluated at 0 and 4. Now this is what we call the setup. Sometimes teachers just want this. Miss Hart, in your physics, do they ask for the setup or do they ask you to actually calculate?
I did the antiderivative one time, so I really don't. It was the infinite one though, because it had C in it, and I did not do that mess.
Okay, I just wondered. I didn't know from the teacher, did they want you just to set it up or do they want you to actually do it? That's why I was asking. Now, I know in Calc 2, most of the time we just want you to set them up. Okay, so that's our actual function. This line right here means evaluate, and I'm going to subtract f of f. Well, I'm going to plug in 0, and I'm going to plug in 4, and I'm going to subtract the 0 term from the 4 term. So I'm going to rewrite this and do parentheses cubed over 3 minus parentheses cubed over 3. And the question is always asked, do you always subtract? And that answer is yes. Think about it. If you go from Anderson to Spartanburg, and then you know that Greenville's in the middle, and you know that it's 30 miles from Anderson to Greenville, and you know it's 60 miles from Anderson to Spartanburg, then how do you find the distance between Greenville and Spartanburg? You subtract 60 minus 30. So whenever you're trying to find a larger number and a lower number, you're always going to subtract. Now again, I don't know how many of you have seen this before, so I'm going from the basics. If we want to speed up, we'll speed up when I find out, you know, how many homework questions y'all are sending in. Then we'll speed up. 4 goes here, 0 goes here. 4 times 4 is 16. 16 times 4 is 64, isn't it?
Yep.
I'll do this one for you. 0. So if you wanted to change that, what is that? 321.33 square units. Let's see, units squared. So 20, let's say millimeters, because that's about a millimeter. This would be 21.33 millimeters squared, if that was millimeters on the bottom. 1, 2, 3, 4. Okay, that is a definite integral. Now let's do another one, and let's put more than one term right here. So let's go with the antiderivative, and let's do 1 to 4 of x to the third minus 1/2 x squared plus 6 dx. All right, I'm going to give you a minute. I got a little clock down here that can, let's see, 59:60. Okay, give y'all a minute to set that one up, and then we'll work on it. Oh,
Don't you start that
don't I start what?
yawning?
I'm sorry. I didn't think it mattered if you could just hear it. It's when you see it. I thought when you saw somebody, that's when it was contagious. Believe it or not, that's a minute. So x to the fourth over 4 minus 1/2 times x to the third over 3 plus 6x to the first over 1, evaluated at 1 and 4. Now I'm writing everything out because I'm not a, I'm not a person that knows how to do derivatives and antiderivatives very well, so I don't want to make a careless mistake. I'm not one of these guys that try to do it in one step, okay? Don't be that person because it ain't gonna work, all right? So x to the 4th over 4 minus x to the 3rd over 6 plus 6x over 1. Now, a lot of people say at this point, well, shouldn't you go ahead and get a common denominator? I would, but that's just me. I would do that first. I mean, after you simplified, I would do that first. So I'm going to, excuse me, I'm going to get a 12 as a common denominator. Unless I'm looking, I think 12 is the least common, but somebody check me. 4 will go into 12 3 times. That'll be 3x to the 4th. 6 will go in there. That'll be 2x to the 3rd. 1 will go into 12 times. That'll be 72x. And you can put all that over 12 now if you wanted to. You could say 3x to the 4th minus 2x cubed plus 72x over 12 evaluated at 1 and 4. Again, this is the setup. So I'm going to go over here and I'm not going to write that 12 3 times. So I'm just going to go over here and we'll say 3 parentheses to the 4th minus 2 parentheses to the 3rd plus 72 parentheses over 12 minus, same thing over again. I'm going to put it in brackets because that minus gives me the willies. 3 parentheses to the 4th minus 2 parentheses to the 3rd plus 72 parentheses over 12, close bracket. And I'm going to put my 4 here and my 1 here. Now I'm running out of room, so I'm going to fold this paper up. And put it right there. So that's going to give me 3. Help me out with 4. Let's say 4.
768.
How much? No, how much is 4 to the 4th?
Oh, 250.
256.
250.
200 what?
256. That's right.
256. Y'all check, make sure. Minus 2 times 64 plus, that's going to be 288. Somebody check me. Over 12 minus brackets 3 times, well, that's going to be 3 minus 2 plus 72 over 12. 762. Somebody help me out.
768.
8. Yeah, I always mess up 3 times 6. I mess it up every time I do it. Minus 128 plus 288 over 12. Somebody do the, let's see, 7 minus 128. That's going to be 650. No, be 640. What's 768 minus 128?
640.
All right, and that'd be 928. What's Do the top. What do you get?
928.
928. So that's 928 over 12 minus brackets. And it's going to be 3 minus 2 is -1. It'll be 71 over 12. Check my math, please. And that's going to be
73 because it's 3 minus 2, so
73.
173 over 12.
okay. Thank you, 73. Okay, so that's going to be 910. I don't know. It's going to be over 1,000. What is it?
No, it shouldn't be over 1,000.
Oh, it's a subtraction. I'm sorry. What is it?
855.
855.
855?
Yep.
Over 12 square units. Now, as you can see, you know why they just want you to set it up now? Because the mathematics is very what? Tedious. So most of the time in a calc situation, unless they're trying to drive home that they're finding the area and they're trying to drive that home, they'll make you do an easy one. But one like this can be kind of cumbersome. Question, great, complaint. Checking something right quick. I'm just checking because some of y'all go into convulsions, and and I go over sometimes. So tell me, is it 420 or 425? When's class in? Say again?
425.
Okay, let's go ahead and end because it's 420, and everybody is Friday. Tomorrow's a holiday. Let me look over the homework. I want to look over it again because I want to make sure of where the actual. Has anybody got into the homework yet? Where you actually start doing the antiderivatives?
Yes.
Which section is that?
I thought you were talking about chapter 4. I'm
Oh,
back
no,
at that. Chapter 5. I have looked at the text,
okay.
not the homework.
Okay. Okay. Well, I'm gonna look at chapter 5 again. Look at their homework again, if y'all don't mind. I mean, y'all can still do it if you want to. I'm not gonna take anything out. I'm gonna get on there and see where the actual steak and potatoes is, because I don't want to. I have a feeling. I looked at the slides today on the PowerPoint, and I looked at 5.3, and I didn't see anything even worth going over. So it may be 5.4 before they actually start doing it.
From line antiderivatives is listed as 4.9.
No, that's Riemann's theorem, I think. That's Riemann's sum, where they actually introduce. I know what they're doing there, but I'm looking at chapter 5. I think it's around 5.4, but I'll have to look. But I just wanted to let you know, homework is not really that big a deal right now, so I don't want you fretting over it. When's the test on chapter 4 due? Friday?
On
Tomorrow,
chapter
yes.
3. Yeah.
Yeah, whatever. Unit 3. When is it due?
Tomorrow.
Okay. So that's what y'all should be concentrating on. If you want to go in and play on the homework for the first 2 or 3 sections, that's fine. But I will, if I look at it tonight, I will put it on the board where you should start concentrating. Because right now, I thought for sure that 5.3 was going to be the fundamental rule of calculus, but it's still not there. So I don't know if they're waiting to 5.4 or not. I'll look at it tonight or tomorrow, and I'll put something on the post and telling you what you need to do. Okay? But go ahead and be looking at the homework if you're done with the test. All right, I'm going to shut off the recording, and I'm going to unpresent.